Hello and welcome again to this course Computational Chemistry and Classical Molecular Dynamics. So far what we have been doing is to consider several types of program statements. So, we had different types of statements such as a conditional statement, executable statement, do statement which is a loop statement, and we started this program to calculate the roots of a quadratic equation. So, you must have seen from the last class that the if statements we used were rather complex if statements. So, many conditions were satisfied. So, if one condition is satisfied, do something, if something else is satisfied, do something, and finally, if none of them is satisfied, that end that if statement. So, these are complex if structures, but if you want a very simple if statement, like suppose I want the absolute value of a number. How do I get an absolute value? If the number is positive, the absolute value is the same as the number, and if the number is negative, then the absolute value is minus that number. So, the if statement will read like this: if into bracket x dot greater dot 0.0 bracket complete, absolute x is equal to x. So, that is if x is greater than 0, then the absolute value of x is x itself. Then the next if statement would be if into bracket x dot LT dot 0 bracket complete, that is if x is less than 0, then the absolute value of x is minus x. So, then you say if into bracket x dot LT dot 0 bracket complete, absolute x is equal to minus x. So, in one line itself you can complete the work of an if statement. Now, in our quadratic equation we have to satisfy many conditions to solve the problem. For example, you look at this program, we started looking at it last time. So, we input the values of a, b and c, that is the first part of a quadratic equation, that is your quadratic equation is ax square plus bx plus c is equal to 0. So, you first want to ascertain that if this a is equal to 0, then it is not a quadratic equation anymore. So, therefore, you have this first condition: if a is equal to 0 and b is not equal to 0. So, these two conditions are satisfied, then you say x is equal to minus c by b. Okay. So, that is how you solve that linear equation. Then you want to write that solution, that the solution of a linear equation x equal to x, x itself is the value. So, if a is equal to 0 and b is not equal to 0, then this is the solution of the linear equation. You will write on the screen and then go to 100. Going to 100 is really saying that it is the end of the program, because you have solved the problem. Then once the first condition, suppose it is not satisfied, then only you will go to the second statement, because if a equal to 0 and b is not equal to 0, then you have done all these operations, then you will go to 100. You will never come to this second part of the if statement if a is equal to 0 and b is not equal to 0. But now suppose b is also equal to 0. So, you will come to this second part of the if statement if a is equal to 0 and b is also equal to 0. So, if both these are 0, then there is no equation. So, we just print that both coefficients a and b are equal to 0, and then you again exit, go to 100. Go to 100 is the end of that program, and then you will end if. Now, suppose both these conditions are not satisfied. So, if both these are not satisfied, then that value of a is not 0, then you will go to the next line. So, you will go to the next line after this end if statement only if a is not equal to 0. So, that means it is a real quadratic equation. So, all these statements that we wrote is just to make sure that you have a proper quadratic equation, and the reason to do that is that whenever you feed data, data could be anything, a can be 0. So, therefore, your program should be written in such a way that whatever your data, it should take care of it. That is why you have to write so many lines here, although you know that the solution of a quadratic equation is just one simple square root divided by 2a. So, now we come to this part. When we come here, we know that a is not 0 and b could be 0 here, does not matter, but a is not 0, that means it is a quadratic equation. So, then you compute this b square minus 4ac, this is the calculation of b square minus 4ac, and if this b square minus 4ac is less than 0, then you go to this 50, line 50. So, if b square minus 4ac is greater than 0, then you will come to this set of parts. So, that your new if statement, there are two parts, if something is less than 0, then do all these, then go to 50, else you do all these things, then go to 100. Okay. So, this is the second if statement. It has again two components. One component if w is less than 0, then you do this part. If it is not less than 0, then you do these things. What are these lines now? RTO FWW, that is square root of WW. So, this line calculates square root of WW. The next line calculates the first root. What is the first root? Minus b plus that square root of b square minus 4ac divided by 2a. In the earlier slide you already saw that 2a is 2 times a. So, this is my first root. Similarly, this is my second root. What is the second root? Minus b minus square root of b square minus 4ac divided by 2a. So, these are my two roots. I just write those two roots and say that these are real root 1 and 2 are root 1 and root 2. So, you have finished the calculation for real roots. Again go to 100. Now, what is this 100? 100 continue end. So, this signifies the end of the program. Now, in case this WW is less than 0, then you will come to this part. Then 50 continue. 50 continue means you just start executing the statements after 50. 50 continue is really a statement which says that you keep going ahead. Okay. So, whereas a go to 100 statement, it tells you to go to this statement, that is continue, then end. So, continue statements and go to statements are just allowing you to keep going ahead in the way that is assigned. So, now I come to this statement. When I come to this particular line, several conditions are satisfied, that is a is not equal to 0 and that b square minus 4ac is negative. Okay. So, now we already know that these roots are complex. Okay. So, this particular line, it is a comment card. So, there should be a C at the starting point, otherwise this the Fortran compiler will not understand what this line is, because this is not an executable statement, this is just an English statement. The roots are complex if something is satisfied. So, this is not a Fortran statement, there should be a comment card. So, just put a C and the first line here, there should be a C here. So, now since WW was negative, so now I will calculate WW as 4AC minus B square. So, it is the reverse of that. Now, we will surely know that this is positive, because if B square minus 4AC is negative, then 4AC minus B square is positive. So, I have calculate now WW, which is a positive number, and calculate the square root of that. Now, you calculate the square root of 4AC minus B square, again this is a positive number. Okay. Then we know that the real part is minus b by 2a. So, whether you have real roots or complex roots, the real part is always minus b by 2a, and if b square minus 4ac is positive, then it will add some more part, as you have done in the earlier case. You see here, you have added minus b by 2a plus square root of that. So, this is the first root and second root is minus of that. So, when I come here, so the real part is always square minus b by 2a, that is the real part. Now, the imaginary part, there will be 2. So, x imaginary part will be root of FWW divided by 2a. Okay. So, this is, remember I have calculated already root of WWW. So, that divided by 2a, that is the imaginary part. So, now your roots are 2, real part plus this imaginary part, and the second will be real part minus that imaginary part. So, there will be 2 roots, x plus iy and x minus iy. So, what this imaginary part is? Just the y part. So, once you calculate that y part, then you again write on the screen, write star comma star complex roots, because when you come up to this part of the program, the roots are already complex. So, once you know they are complex, now you write star comma star root 1. Okay, this is again written on the screen, real part is written because real part is minus b by 2a, then imaginary part is equal to x I m p t. So, in the first root it is the real part and plus imaginary part, and the second root will be the real part minus the imaginary part. So, I am saying now x imaginary part 2, this is the second root, that second root is the imaginary part is x minus y I y. So, this minus x imaginary part is nothing but minus y. So, what do I write now? The final root, write star comma star, that means again write on the screen whatever is in the quotation mark, it will write on the screen, then it will also write the real part, then it will write the real part here which is minus b by 2a, then imaginary part is minus this. Okay. So, this way you have written the two roots on the screen, x plus I y and x minus I y, and once you write that, your job is done, it goes to 100 continue, end. So, you see that with all these lines will almost be about 30 or 40 lines. You have taken care of all possibilities, a equal to 0, a not 0, real solutions and complex solutions, and your right statements are such that on the screen you will know that whether it is a real root or a complex root. So, this completes our calculation of the roots of a quadratic equation. Okay. Then we will proceed to our next topic. So, now again before we go to the next topic, let us summarize again what we have done. Okay. So, let us see what are the main ingredients of a program again. This you have to keep thinking again and again, so that this is the program structure. It will have program structure has an instruction which carries mathematical operations such as evaluating a formula, okay. Then repeating a calculation until a condition is satisfied. This is another way of doing. Some of the other things we have not seen, allocation of storage. So, this we will come now, because when you calculate many results, you have to store those things in the memory. So, how do you create storage in a program? Then reading inputs from files, this is what we will be doing now. So far whatever inputs we had, you are taking directly from the screen and you are writing the output as well to the screen itself. But this is okay if you have one number to read or two numbers to write. Suppose you have 100 numbers to write. So, it is very difficult to read 100 numbers from the screen, or it is very difficult to give lots of data from the screen to the computer. It will be too much, and suppose when you are typing the 70th number you make a mistake, the whole program will crash. So, therefore, the way we read inputs and the way we write output can be done from files rather than the screen. So, that we will consider shortly. And finally, one of the important thing is you should know how to terminate a program, because if you do not terminate a program well, then it will go on doing the calculations and you will never know whether it is finished or not. So, therefore, just as starting a program properly is important, terminating is also important, because once it terminates, if it does not terminate, then it should give some message that something is going wrong. Okay. So, terminating is also important. So, these are the main ingredients. Now, before we consider several other aspects, we have not talked much about commands in Linux. So far what we did, we uploaded a Linux operating system and in that started creating files by a vi command, correct. Then once you create the file, you save the file, then compile the file by gfortran file name and then execute. So, the only commands we know so far are your vi command and gfortran command and /a.out. Okay. There are now several other important commands in Linux which are very, very useful when you do programming. So, in this slide I am listing all those useful commands, and there are always help commands in Linux. So, you can always get a help on that command. So, now let us see which are some of the most useful commands in Linux. So, the first line says ls space minus l. So, this ls space minus l lists all the files in a directory. So, this is a very useful command, because you want to know what are the files in a directory. Sometimes your file may not be in the directory you are looking for. So, therefore, ls space minus l, remember that it is not ls minus l, ls space minus l, it lists all the files in a directory. If you just do ls, it will still give you a list, it will give you a short list. When you say ls space minus l, it will give you a long list. That long list will tell you what is the size of the file and so on. Then the other command which you will need all the time, you may want to create new directories, because it is always good to have several directories and each directory will do a different job for you. So, to create a directory you will say mkdir new directory. So, what you have done this with this command is you have created a new directory with the name new dir, and once you create a new directory you may want to go from the present directory to the new directory, right. You want to change the directory now. So, there is a structure, there are directories, there are subdirectories, subdirectories of subdirectories, all Linux files have a structure like that. So, when you create a new directory, so this new directory also will remain in the present directory, and you may want to go from the current directory to this new directory. So, that is how you use this command cd new directory. That means you have changed the directory from the present directory to new directory. Now, if you want to go back to the original directory, cd dot dot. So, it will go back to earlier directory. So, what are the commands we have seen so far? Listing the files through ls command, creating a directory, changing a directory, and going to the new directory and coming back to the new directory. So, these are these 4 commands. Then the other command you will need very often is copying files. So, you may want to make a copy of a current file. So, the command is cp. cp is a copy command, copy file 1, file 2. What does this command do? It copies file 1 to file 2. So, after this command there will be 2 files, file 1 and file 2. Okay. Now, suppose you want to remove this file. Okay. Suppose you want to remove any file, rm file 3. So, what does this rm do? It deletes a file which is named file 3. But remember, be very careful when you delete a file, because once you delete a file you may not be able to get it back. So, always when you delete, be very careful. So, it is good to have copies of all your files and save it on a hard disk. Suppose you have done some work for several days, you have all those files and maybe your hard disk may crash after a few days. So, whatever work you have done, make it a habit to save all those files on either a pen drive or some other hard disk. Okay. Again, to do that you can use a copy command to save from your hard disk to your external hard disk. And finally, there is a help command. So, when you say help, it will list all the commands that are of use in Fortran. Okay. And in many compilers there is also a man command, man is a manual. So, if you say man F77, it will give you all the features that are there in this command F77. Man is a manual command, help is a help command. So, as you go along learning, you will find that this help and man will be very useful. And similarly, of course, you can go to website, go to Google and say what are the Linux commands, what are the details, and once you start doing computing for 2 or 3 weeks, all these commands will become part of your vocabulary and you will start using them. So, it is not so difficult, but you just need a little bit of practice. So, again this summary once again, what was our list? Instruction, repeating, allocation of storage, reading inputs, terminating. This is a repeat of the last slide, just to remind you what are all the main ingredients. So, now we will come up with a new topic. This is a very important topic, because so far what we have done, we have used several variables. What are the variables we used? WW was a variable and RTOWW. So, every variable took on one value. Okay. So far whatever computing you have done, each variable takes one value, but often we need variables which are dimensioned. For example, many of you may be knowing what are matrices. What is a matrix? Matrix is an object. So, suppose I have a 10 by 10 matrix. A 10 by 10 matrix, there are 10 columns and 10 rows. So, this is a 10 by 10 matrix. So, for a 10 by 10 matrix, there will be 100 objects associated with that matrix. So, the question is, you know, in mathematics you will use A, I, J, where I and J are subscripts, but a computer does not understand subscript because every line statement is given in one line. Okay. So, therefore, you should have a mechanism to distinguish an object which is a normal variable like the root 2 or WW you saw before, or subscripted variables. What are the subscripted variables? Like your matrix Aij, Aijk, or there could be just a vector. So, what is a vector? Vector, suppose a 3-dimensional vector x, y, z, or you can call it Ai, I going from 1 to 3, A1, A2, A3. So, this is a one dimensional variable with 3 components. A matrix is a 2-dimensional objects. A 2-dimensional objects will have rows and columns. So, similarly you can have 3-dimensional objects, 4-dimensional objects. Now, the reason for this is that you have often large data which has a similar meaning. So, instead of giving so many names for each variable, it is good to give a subscripted variables. For example, you know that in your class you have roll numbers. Why do you have roll numbers? Why is it that, why did the roll number come in the first place? Or now you have PAN numbers, you have Aadhaar numbers. Why are we having these numbers? Because numbers are easier to rearrange and manipulate rather than names. Okay? So now the first example I will consider is a dimension variable which I am calling it. So, I will call this a dimension variable. So, I have called this dimension variable temp val 365, 24. This is the first dimension variable we are using. The reason I am calling this dimension variable temp val, there is a reason. So, what we want to do, we are all chemistry students. So, what we want to do, we want to know what is the average temperature of the atmosphere in the whole year. So, this is my experiment now, chemistry experiment. It is not a great experiment in terms of new information, but it is useful also, it is useful. So, I want to know the average temperature of my atmosphere in the whole year. So, how will I do that? One option is keep on measuring the temperature every minute and measure it throughout the year and get an average. That will be too much because you know how much data you have to collect. So, what I want to do, I want to collect data every hour for 24 hours, then every day of 365 days, assume that it is not a leap year, and I want to store that information in an array called temp val, and this is now an array. This is not a simple variable like WW or root 2. This is an array with 365 rows and 24 columns. Okay. So, this is an array. So, this is a subscripted variable. So, subscripted variables are dealt with differently than non-subscripted variables. Okay. So, as I have described, the whole thing is written in the slide. You can look at it at leisure. I have created this subscripted variable called temp val, and how do I use it in a program? That is our next task. Okay. So, this is not, this temp val takes 365 into 24 objects. It is not a single number, it is a very large object. So, the way it is addressed is given here. So, this particular slide tells you how to use arrays. So, the first thing you have to do if you are using an array is to declare the size of the array. You see that first statement, when you have an array, you declare its dimension. It says dimension temp 365, 24. Earlier slide I had called it temp value, now I am just calling it temp, because why do we give very large names? Temp will represent just 4 characters. So, and temp also tells you it is a temperature. So, remember, give names to your variables which have some sense to you from your chemistry or physics point of view. So, I have created an array temp which has 365 rows and 24 columns. So, whenever I have such an array, my read, so the way it is referred to in the program is given below. So, now I have already made the measurements throughout the year, computed measured the temperature for 24 hours a day, each hour once, 365 days. So, this is my data. I have arranged the data into 365 rows and 24 columns. So, the way I read it is in this manner. So, my days go from 1 to 365. So, one loop is there to read the row index, second loop is there to read the column index. Now, look at this statement, do 100 I going from 1 to 65. So, what does our knowledge of do loop tell me? So, this variable I takes the value 1, does all the thing up to 100, comes back, takes the value of I equal to 2, go all the way to 100 and come back. This it will do 365 times. So, when I am doing with I variable 365 times, I define a second variable. Now, this is not I, this should be j. So, do 90 j going from 1 to 24, because it is a second variable. Okay. So, first variable is I, second variable is j. So, what is the meaning of that? J goes from 1 to 24 up to 90. So, the statements up to 90 are continued 24 times because J goes from 1 to 24. Then once J does 1 to 24, it will go to 100, then I will increment. Then again J goes from 1 to 24, I will be incremented. So, these two do loops allow me to read those values of temperature for 365 days and 24 hours. So, the way program will run, I will be 1 first time, J will be 1, read temperature 1 comma 1, first day, first hour, then goes back, then J becomes 2, first day, second hour, then J is 3, first day, third hour, J is 4, first day, fourth hour, until J is 24, it will read this, that is first day 24, then it goes back to 100 continue, then it goes to this first line, then I is equal to 2, second day. Now, second day, first hour, second day, second hour like that, second day up to 24 hours, come back, third day, first hour up to third day 24, like that it will do for all the 365 days 24 times, then this whole part is over. So, what is the advantage of this now? The advantage is through this set of two loops, I have read all my data and put in that variable temp I comma j. Now, now let us see the meaning of this. Suppose I say temp 22 comma 33. What is the meaning of that? It is the 22nd day and 33rd hour. But you know that there is no 33rd hour. So, there will be a problem here. Okay. See what was our array? 365 and 24. So, when you have something like this, your row should be between 1 and 365 and column should be between 1 and 24. So, if you give like this, there will be a huge problem because the computer does not know what is the 33rd hour. The computer does not know because you gave only 24 hours. If you want to read more than 24, your dimension should be more than 24. So, this particular thing will give an error, but if I have say 22,2, that means it is the 22nd day and second hour. Okay. So, this is the meaning of this. Now, let us see, before I conclude, I want to see what would you do. Suppose you are in charge of the railway reservation system and you want to save the information about the reservations for all the trains for all the possible days, because now the system, you know that very well, that when you reserve a ticket on your computer or PC, you are able to reserve sitting anywhere in the country. So, how should the array be to save all the information about the reservation system? That is what we will consider next time. So, I will conclude this lecture now. So, what we did this time is looked at some Linux commands, looked at some if statements. There are many ways of writing if statements. Then finally, we initiated this time use of arrays. Arrays are very, very crucial. So, we will again continue use of arrays in the next class. So, I will close here. Thank you.